All right, so now we're on page 8, operations and scientific notation. This is the other piece that is unfortunately glaringly overlooked in high school curriculum. You've got to be able to work with this stuff. You've got to be able to add, subtract, multiply, divide, do squares and square rooters with this stuff. And so we're going to break this down into easy pieces and parts. So page 8, operations and scientific notation. We're going to start with multiplication, which, believe it or not, is actually one of the simpler ways to work with this stuff. Okay, so multiplication critical rules right there at the top of the page. You multiply the coefficients, retain the bases, and add the exponents. So write that into the spots there. You multiply the coefficients, retain the bases, and add the exponents. And just in case you're rusty on this stuff, adding a negative number is the same as subtracting a positive number. Put this up. Adding a negative is the same as subtracting a positive. So there it is. Multiply the coefficients, retain the bases, and add the exponents. So we'll start with 1. Now, this is where paper and pencil is going to be kind of critical. We have 4.75 times 10 to the third times 2.43 times 10 to the 7th, and I got a $20 bill that will tell me that back in school, when you encountered something like that, they handed you a calculator and said, go beedly, 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 have a nice life. Well, we're not going to do it that way. We're going to write it down. Here's why we're going to write this down. This is not a math course. This is a science course. In science, we write everything down. And this is a good spot for me to point out something. Science, medical profession, first responders, and military have this one ethic that's in common. And it goes like this. If it ain't on paper, it never happened. And in science, we put everything down on paper. The other reason that we're going to do this is because there's a mental process that you need to be aware of. When you just grab one of these, and yes, they're handy and we need them, but when you grab one of these and just start mashing buttons, there's a section in your brain that is engaged. If you actually write it down on paper, it's an entirely different section of your brain that is engaged, and they have done MRIs to show this. The point being is that when you're doing math and you write it down, you are engaged in the math process more than you are if you simply mash numbers. So that's what we're going to do in this course. So we have 4.75 times 10 to the third times 2.43 times 10 to the 7th. Okay, we're going to stack them and split them. Now, this is what you use a calculator for. So, 4.75 times 2.43. I got 11.5425. I'm going to round that to 0.543. In this course, if we go out 3 decimal places, that's going to take care of 99% of what we'll be doing here. So I'm showing 11.543. Okay, we're multiplying. So now we add 10 to the 10th. And is it in proper form? No, not really. So we're going to make that 1.154. And I went to the left, so that's going to make that 10 to the 11th. Now, another thing I want to point out. I am aware that some of you have calculators that will do the whole shebang for you, including the scientific notation and the adding of the exponents and all of that stuff. I'm telling you now, don't do that. That is the road to perdition. Here's why. This is a TI. You might have a Casio, or you might have some Wally World, who knows what the hell it is. The point is, they all have different algorithms in them. And here's what is going to happen if you rely on the scientific notation function in your calculator. You will eventually, and inevitably, wind up with an answer where your exponent is off by 1. And you might say, well, is that all that important? Well, yeah, it is. Because if your exponent is off by 1, that means that your answer is either 10 times too big or 1/10 what it ought to be. You know, that can be a real problem, especially if you're working for NASA. Oops. All right. Here's the other thing. Guys, if you really need a calculator to go 3 plus 7, you've got bigger problems than anything we're going to be addressing here. Seriously, guys. Use your calculator for this. Use your gray matter for this. And what you're going to find is that you will make fewer mistakes that way. And when you do make mistakes, you're going to catch them more quickly than if you do everything here. All right? So, moving on. The next example. 3.72 times 10 to the 7th. Times 1.67 times 10 to the negative 2. Stack them, split them. Use the button box for that. And I got 6.212 times 10 to the 5th. All right, so that's multiplication. Next page, page 9. All right, division, critical rules. Right at the top of the page. Divide the coefficients, retain the bases, and subtract the exponents. So once again, fill in the blanks. Divide the coefficients, retain the bases, subtract the exponents, and note that subtracting a negative number is the same as adding a positive number. Subtracting a negative is the same as adding a positive. Might want to write that one down somewhere. All right, so now we have 9.35 times 10 to the 8th. Divided by, or over, 3.54 times 10 to the 4th. Okay, stack them, split them, calculator for that. 9.35 divided by 3.54, 2.641. Times 10 to the 4th. Piece of cake. Next example. 8.62 times 10 to the 6th. Over 3.97 times 10 to the negative 3. Okay, stack them, split them. .62 divided by 3.97. Oops. 3.97. Yeah. I got 2.171 times 10. Okay, subtracting a negative is the same as adding a positive. So that's going to be 6 plus 3, 10 to the 9th. Right. Adding and subtracting. Adding and subtracting, and now we're going on to page 10. Adding and subtracting can have extra moving parts involved, believe it or not. It can be a little more complicated. Okay, so critical rules for adding and subtracting. Exponents must match. Write that down. Exponents must match. Assuming that they do, then we add or subtract the coefficients, we retain the bases, and we retain the exponents. Leave them alone, don't touch them. So let's take a look at this first one. Okay, so we got 6.72 times 10 to the third plus 2.97 times 10 to the third. The exponents match. All right, so we can go, this one's good to go. This one's pretty straightforward. 6.72 times 10 to the third plus 2.97 times 10 to the third. Stack them, split them. 6.72 plus 2.97, 9.69 times 10 to the third. We don't touch them, we leave them alone. Why? Well, remember, we're adding, and all we're doing was we're just counting ducks again. I got 3 ducks here, I got 4 ducks there. How many ducks I got? I got 7 ducks. All right, so that's what we're doing here. We're just counting them up. Now, let's look at this next one here. 9.56 times 10 to the 5th minus 8.47 times 10 to the 4th. These exponents don't match. So, I'm going to show you how to cheat your way around this one. Watch how I do this. 9.56 times 10 to the 5th see how I'm spacing that out? I'm giving myself some room to work here. Minus 8.47 times 10 to the 4th. Stack them, split them. All right. Now, here's where the cheat comes in. These exponents don't match. Well, I'm going to make them match. I'm going to change 10 to the 4th to 10 to the 5th. And that one doesn't come out very clearly. I'm going to try a different marker here. Now that's better. Okay. All right. So I raised it from 10 to the 4th to 10 to the 5th. So my exponent went up. That means my decimal goes to the left. Don't forget this. Okay. So now this is going to become 0.847. So now that'll be 9.56 minus 0.847, and I get 8.713. Times 10 to the 5th. Now, some of you may be asking, could I have changed the 5 to a 4? Sure, you could have done that too. Either way, it'll work, so long as you get the exponents matching. That's the bottom line. Okay. Page 11. Squaring and cubing numbers in scientific notation, critical rules. Okay, so page 11. Critical rules. You square or cube the coefficients, square or cube the coefficients, retain the base, and multiply the exponents by 2 or 3. So once again, you square or cube the coefficients, retain the bases, multiply the exponents by 2 or 3, depending on whether you're squaring or cubing. So, first example, we have 2.56 times 10 to the third all squared. All right, so I'll square the 2.56. 2.56 squared. I got 6.554 if I round it. And I'm going to multiply the exponents, not add, multiply. So that'll make it 10 to the 6th. Now, let me explain why this one works this way. Because we've been so conditioned to add exponents when in any kind of a multiplying process. And I see this all the time. People are working through a problem, they see a number like this where it's squared, they see the 3, they see the 2, and they go, oh yeah, 10 to the 5th. No. The way to remember, to keep a handle on this is to remember what is an exponent. An exponent is an instruction. So this instruction here, that 2, is telling me to write 2.56 times 10 to the third twice. And multiply. And we already know what the answer is. 6.554 times 10 to the 6. So that's why. Okay. Next example. Example number 2. 2.56 times 10 to the third cubed. So, I'm going to cube the 2.56. And I got 16.777. Times 10 to the 9th. Next example. Example number 3. 3.12 times 10 to the negative 6 squared. All right, so 3.12 squared. I got 9.734. Times 10 to the negative 12. Remember, multiplying unlike signs results in a negative. Multiplying like signs results in a positive. That's at the top of your page there. Okay, so remember, multiplying unlike signs results in a negative. Multiplying like signs results in a positive. Okay. Example number 4, 3.12 times 10 to the negative 6 cubed. Cubed. I got 30.371. Times 10 to the negative 18. Next page, page 12. We got to be able to do square rooters, and we got to be able to do cube rooters. Okay, critical rules. Exponent must be divisible by 2 or 3. Exponent must be divisible by 2 or 3. And this is the cheating way, all right? Assuming that it is, then we're going to square root or cube root the coefficient. We're going to retain the base, and we're going to divide the exponent by 2 or 3. We're going to divide the exponent by 2 or 3. So, first example. Oh, also, and recall that dividing unlike signs results in a negative, and dividing like signs results in a positive. Don't forget that part. So the first example we have is square root of 9.46 times 10 to the 6. Okay. Now remember, even though you don't see them there, what goes here? 2. We generally don't put that 2 there for square roots. Okay, so we're going to go square root of 9.46 I got 3.076 times 10, 6 divided by 2, 10 to the 3rd. Example number 2, cube root of 9.46 times 10 to the 6. Okay. The exponent is divisible by 3, so we're all set. So, So, if you're using a TI-30, what we do here is you're going to hit second, and then you're going to see the little chevron. Did that backwards. Second. Was right the first time, so I hit 3, second, cube root, there it is. 9.46, and I got 2.115 times 10, 6 divided by 3 squared. Third example. Square root of 8.1 times 10 to the 5th. Okay, now that exponent is not divisible by 2, so we got a problem. How are we going to get around that? We're going to cheat. I'm going to drop that down to 10 to the 4th, which is divisible by 2, and that's going to make this 81. Okay, the square root of 81, don't need a calculator for that. I know that's 9.0 times 4 divided by 2, 10 squared. Now, I want to pause here and show you something. Like I said, this is how we can cheat and work around it. But down the road, you may encounter something that requires you to not go that route. We won't need it in this course, but let me just show you what I mean by that. So let's take our original problem here, 8.1, square root of 8.1 times 10 to the 5th. So now I'm just going to do the square root of 8.1. I got 2.846. Times 10. And what do we do with the exponents? Well, we divide them by 2, so 5 over 2. We got a fractional exponent. 5 over 2 is the same as 2.5. And this is where we get into logarithms, which we're not going to do in this course, but let me just show you what I mean by that. 10 to the 2.5 equals that equals 316.228. So we'll multiply those. Comes out pretty close, doesn't it? Okay. But again, we're not going to need to do that in this class. But I just wanted you to see what it was. All right, moving on. One more example. Okay, the last example is the cube root of 8.1. Times 10 to the 5th. All right, so what I'm going to do here, we're going to cheat. I'm going to drop that 10 to the 5th down to 10 to the 3rd. So my exponent went down by 2. That means my decimal is going to go over by 2 to the right. That's going to make it 8/10. So now I'll go for the cube root of 8/10. And I got 9.322. And 3 divided by 3 is 10 to the 1st. And there we are. All right, so that covers it. Now you'll find in your book from pages 13, 14, 15 and 16. Okay, some examples for you to work out. So page 13 has the examples for you to try. Do them the way I learned you. Page 14 has the answers and the how-tos. 15, some more examples for you to try out. And 16, answers and the how-tos. Now, there may very well be some typos in there. So if you see them, all I can say is I don't have an editor, and it was 11:30 at night when I did that, and I'd had about 100 beers. So that's my excuse, and I'm sticking to it. So there you go. That's stuff to keep you busy. And when we talk again, we're going to talk about the metric system. All right, have fun.